Question number 8 tells us or asks us to determine if the following ordered pairs are solutions to the equation 2x plus y equals 12. And you can see here we've been given a set of 3 ordered pairs, and we have to determine, is each of these ordered pairs, each of these points, does it produce a true statement for the given equation? Is it a solution? So let's go ahead and dive in and take a look here at the first ordered pair. So is 3 comma 5 a solution to the equation 2x plus y equals 12? Select the correct choice below and fill in the answer box to complete your choice. So as we did earlier in this practice test, we know that a solution to an equation means that if we take the ordered pair, so in this case we want to deal with 3 comma 5, and the 3 refers to the x coordinate, and the 5 in this case refers to the y coordinate. If we take this ordered pair, plug it into the given equation, which in this case is 2x plus y equals 12. If we substitute this ordered pair into the given equation, do we get a true or false statement? If we get a true statement, we know that the point is a solution. If we get a false statement, we know the point is not a solution. So let's go ahead and determine if 3 comma 5 is a solution to the given equation. So we'll go ahead and start and say, well, 2x, but in this case, we're not going to use the x variable. We're going to substitute the x from the given point, so in this case 3, plus y, but again we're not going to use y. Instead we're going to substitute the y value from the point, so in this case 5, is equal to 12. And what we want to know is this true? When we clean this up and simplify, does the left hand side equal 12? Well, let's find out. When we distribute here, 2 times 3 gives us 6. We can distribute here. Positive 1 times 5 is still positive 5. Does this equal 12? Well, 6 plus 5 is 11, so we end up with the statement 11 equals 12. Is that true? No, certainly not. The number 11 is not equal to, does not have the same value as 12. This is clearly a false statement. And so we can say that for the first part of this question, is the solution to the equation 3 comma 5? Well, certainly not. We did not get a true statement, and so don't just click on the answer and move on to the next part, because there is another component to this question. So yes, we have to choose the correct answer if it is a solution or not a solution. But look here further down the line. We have to actually give them a reason why this ordered pair is not a solution. So we're going to say no, because when 3 is substituted for x and 5 is substituted for y, simplifying the left side results in, well, what did the left-hand side result in when we simplified? It resulted in 11, which does not equal the right-hand side. So again, the right-hand side is 12, but we get an 11 on the left. That's why the point 3 comma 5 is not a solution, because it does not yield a true statement. All right, and I'm going to go ahead and erase some of this so that we can have some more room to test the remaining 2 points. So we have the given point next to test is 6 comma 0. So 6 comma 0 into the equation 2x plus y equals 12. So let's go ahead and test. So 2x, but again we're going to plug in the value of x, in this case 6, plus y. Well, in this case we're not going to use the y, but rather we're going to substitute the value for y from our point and determine, is that equal to 12? Well, let's clean up the left hand side here by distributing. So 2 times 6 is 12. Distribute here. Positive 1 times 0, well, is still 0. Does that equal 12? That's what we're testing. Yeah, certainly, right? Because 12 plus 0 is still 12, and 12 does absolutely equal 12. That is a true statement. So we can say definitively that the point 6 comma 0 is a solution. So yes, because when 6 is substituted for x and 0 is substituted for y, simplifying the left-hand side results in 12, right? We got a 12 on the left-hand side when we simplified, which equals the right-hand side. So that is why 6 comma 0 is a solution, because the left-hand side is equal to the right-hand side. All right, and last but not least here, let's go ahead and make just room for our last point to test. So we will plug all of this in and see what happens. So this time we're going to test the ordered pair 0 comma 12. So 0 comma 12 into, again, the same equation that we've been using, 2x plus y equals 12. So let's see what happens. So 2 times x, but again, we're going to substitute 0 in for x, plus y, but again, we're going to substitute 12 in for y, and determine, does the left-hand side, when simplified, equal 12? Well, distributing here, 2 times 0 gives us 0, plus distributing here, positive 1 times positive 12 is still 12. Does this side, the left side, simplify to 12? Yeah, it sure does, because 0 plus 12, still 12. So we end up with 12 equals 12. Again, absolutely a true statement. So we can say for the last part of question 8 here, is 0 comma 12 a solution to the equation? Yes, it is. Oop, don't not know. Yes, it is, because when 0 is substituted for x and 12 is substituted for y, simplifying the left-hand side results in 12, which is equal to the right-hand side. So just be careful here. Notice that little, mistake that I almost just made. With the first part, the choice A was no, choice B was yes. But here in the second part, choice A became yes, choice B became no, and then it switched back again for the last part here. Choice A was no, choice B was yes. So really be careful here and don't make the little mistake that I almost made in assuming that each of the A and B options are the same for all three of these points. So you've got to be careful when selecting. So in this case, for the last part, is 0, 12 a solution? We're going to select B because yes, it is a solution, and when we simplify, we get a 12 on the left. And that's all you have to do for question 8 to determine if the three ordered pairs are solutions to the given equation.